Hi, I will show you how I use my own website hochohmig in my electronic projects like this one. Okay, so let's jump right into it. Here you can see the start page. There are different modes, where I think the first two are the most important ones, and we will just start with voltage divider design. Here are some tool tips for helps, and as you can see here, we have a picture here. This is your input voltage, U1 or V1. Those are your two resistors, and this is your output voltage. And usually, maybe when you are measuring voltage with your microcontroller, then you want to scale it down, the voltage, to be able to measure it. So for example, if you have a voltage of 12 volt and you want to scale it down to 3.3 volts, then you can just input it here. You can also set the mode to V1 constant, which is voltage divider mode. We will get to the other mode in just a moment. And also we can set the highest E series. So the E series is actually the problem. So you can only buy resistors in those values that are defined, and for example 2.22 ohms are not available, and it makes things easier if you can use, for example, E24, because then you only have to have 24 values for each decade in stock. So that is what I want to do. I want to use E24, and just like that we have results here, and we can choose from them. I personally would recommend to use a bit more margin, just to be safe if the voltage is a bit over 12 volt, but that's not the problem at the moment. So in my project I have a buck converter. The buck converter, let me switch to the schematic. This is not a very nice schematic, but as you can see, the buck converter here lowers those 5 volt to 3.3 volts, and with this resistive divider here, this is going to the feedback pin, and here this converter TPS62A01 from TI compares the voltage at this pin with an internal reference, and so it can control the output voltage. I sometimes read in datasheets that you should choose one value and then calculate the other one, and then choose the next E value. But the problem with this is that with E24 values, you won't get a very exact output voltage. And this is where hochohmig comes into play, because let's just input those values here. So voltage divider, V2 is constant because we have a voltage regulator, and V1 is 3.3 volts, and V2 we have to check in the data sheet. It is the feedback voltage. It is always given in the data sheet, and it's 600 millivolts here. So let's just input that here, 0.6. The other things are nearly correct. Let's just set this a bit higher, and this just gives me a lower power loss, so this is better. And E24, as you can see with E96, we would have a lot of more possible values, but I want to use E24, so I'm choosing this solution, and my 3.3 will be 3.32. That is fine. So now let's check the tolerances of this. For this we just click more, and already get now our values in our tolerance calculator. Now we need to put in the tolerance. I guess it's not that good, because I want to have 1% resistors I want to make it cheap, and I also want to enter the exact values from the data sheet, and that is 591609. Okay, that's it. And what I also saw on the data sheet, let's click on miscellaneous. Now our picture changed. We also have the leakage current here. So there will be a small leakage current into that feedback pin, which is here. And that is given in the data sheet. It's 100 nanoamps, and unfortunately there's no typical and minimal value, so we will just assume absolute input. We will just assume minimum value of 0, maximum value of 100 nano, and nominal value we will just say 10 nano. This doesn't care very much because, as you can see, 3.32, and if we would change it, it will be a bit higher. But this especially comes into play if we choose higher values from another decade. So here we would have a significant change with the leakage current, as you can see. Yes, so this would be very significant. But we don't have it here, so we don't care. Okay, so now our output voltage is within range 3.22 and 3.43 volt. So now let's do the final check if we can meet the specs from our microcontroller. We use the RP2350 from Raspberry Pi, and the I/O voltage has a very big window, which is easy to hit. But we also have the USB voltage, which needs to be within 3.135 to 3.63, and as we can see, no problem. So that's fine. We are good into that window, so that is fine. The same could be done for the 1.1 volt. So let's quickly enter that here. The divider was 10K and 12K. So that is still true, that is true, that is the same. So we have 1.07 to 1.13. And the datasheet says us we need, yes, so that is a bit more tricky, but is still fine. If we would now not meet it, we would need to use 0.1% tolerance resistors, which would help a bit. But to be honest, I want to make it cheap, so that is fine. Okay, we have two other modes. Decode marking of SMD resistors, I think that's quite obvious. Some SMD resistors have small markings on it, especially the bigger ones have markings on it, the smaller ones don't have it. And it's not quite obvious what the marking says. So just enter it here and it will give it to you. It's 10 ohm. The last mode is the wire length calculator. Here you can just enter your values of a wire you want to calculate. This one is 100 meters, maybe 1 square millimeter. The current will be 10 amps and the copper is very hot. It's summer, it's 40 degrees. So we have a drop of 18.5 volt. Okay, so we now saw how I designed and choose the voltage dividers for this electronic. We have two buck converters here, one for the core voltage, one for the 3.3 volt, and we will now measure those four PCBAs. If you're interested in this organ, just subscribe. And we will now measure the tolerances and see if the theory matches with reality. By the way, what is hochohmig? hochohmig is just a German word for high resistance. So there's no English word for that, but in German there's hochohmig and the opposite is niederohmig. That's it. And let's just power it on with a power bank and take this out. Okay. .3 is here. 3.36 and 1.11. Okay, that is fine. .34, 1.1. That is perfect. This is slightly modified, but the regulators are the same. .1, bang on. And the last one. .34 and 1.1. Okay, so that's it, perfect. By the way, this is the test PCBA. You can just assemble those together like this and test this with this, but that's part of another video. Okay, that's it for today. Bye.